So last round of curve fitting, this time what I've done, the only thing I've changed on you is rather than giving you the information verbally, I'm actually just giving you a picture. So based off of that picture, can you find a function that fits the information that I have? And so again, it really comes down to where's my vertical asymptotes, where's my x-intercepts, right, and where are my horizontal asymptotes. That really kind of is the big three. So vertical asymptotes, we can see there's one at -3 and one at 4. So that tells me that my denominator, I need x plus 3 and x minus 4. I do have a x-intercept that's occurring, it looks like it's occurring right at the y-axis. So that basically means x has to be up in the numerator. So I have x equals 0 as a 0, x equals -3, and x equals 4 as my zeros upstairs and downstairs. So I've got my vertical asymptote and I have my x-intercepts. What about my horizontal asymptote? Well, the horizontal asymptote looks like it's y equals 0, and I think I have something that already got it done, right? Because the degree upstairs is 1 and the degree downstairs is 2. So we basically have the degree is less than the degree. So we have y equals 0. So I've got it. F of x equals x all over x squared, I believe, minus x minus 12 is the function that fits the situation that's shown. And again, you could easily, well, I'll go ahead and do it. I think I got time. So let me clear out what I did previously. Clear and clear. And so we'll enter this function and see if it looks like the one I've got. So x up in the numerator, and down on the denominator I have x squared minus x minus 12. And that looks like the function I'm looking at. All right, so we pretty much nailed it. All right, so good work for us. Next example, again, we're looking for vertical asymptotes, x-intercepts, and horizontal asymptotes. Right, those are the big three. So in this case, I can see it looks like I have a vertical asymptote at 3. So I know I need x minus 3 down in the denominator. An x-intercept is occurring at 2, 0. Right? So that means I need an x minus 2 up in the numerator. Okay? And then it looks like I have a horizontal asymptote at y equals -1. All right? And so good news and bad news here. The good news is that I do truly have a horizontal asymptote because my degree upstairs matches my degree downstairs. However, if we stopped here, right, the lead coefficient is 1 and the lead coefficient is 1. So for my graph, right, for my function at the moment, I have y equals 1. So this is real easy to fix, right? So all I got to do is negate the top, right? Because what this will create, I still have the 0 of 2, but if I distribute, we get -x plus 2 all over x minus 3. And so I'm guessing there's my f of x. So my 0 is still 3 in the denominator, vertical asymptote. -2 still makes, positive 2 still makes the numerator equal to 0, so my x-intercepts is still intact. But now my lead coefficient divided by my lead coefficient gives me the horizontal asymptote that I need. So there's your little trick with that. Just multiply the top or bottom by a negative. So again, to verify that we're on the right track, let me go to my Desmos, and we've got -x plus 2 in the numerator and x minus 3 in the denominator, and that seems to fit the graph that I'm looking at. All right, so we've nailed it again. So we obviously know what we're doing. All right, so that officially wraps up 5.5, and I believe it wraps up chapter 5. So a lot of polynomial work, a lot of zeros work, so hopefully you learned a lot, you gained a lot of knowledge algebraically, and again, if you have questions, please come see me for an office hour, schedule an appointment, ask your question on Canvas, send me an email, whatever it takes, all right? So I'll see you guys later. Well done.